Okay, so the last subtopic in chapter topic 8 is actually about thermal expansion, which is 8.4 lah. In this chapter, you have to know about two things. One is about definition, and one is about how to use the equation. So basically, thermal expansion, we will discuss about three types of expansion. One is linear, another one is area, another one is volume. So linear expansion, as you would expect, it involves with the increase in length. Right, increase in length, that means linear. And then change in area, like initially you have small area, when you heat it up, increase or decrease when you cool it off. So the change is what we call area expansion. Okay, and then we have volume expansion as well. So this is area, this is length, and this is volume. So volume, you will expect it to look like something three-dimensional. Maybe it's increased in that direction as well. Okay, so that one is in terms of like how it goes. So you have a change in length, we call that one as linear expansion. If you have a change in area, we call that one as area expansion. And if you have a change in volume, we call that one as volume expansion. Mainly it is because as the temperature increases, molecules will start to vibrate more, and then they expand. Okay, if you want to focus on length first, you have a specific formula for that one. So change in length is actually equals to alpha L0 delta T. So L0 is the initial length here, like this one is L0. Delta T is change in temperature. Let's say initially it is 40, final is 60, so 60 minus 40. And then for change in delta L, that one's delta L, the difference between final and initial. So final length, we call that one as L. Delta L is basically the difference of L and L0. Maybe I can write it down. Delta L is equals to L minus L0. Alpha here is the coefficient of linear expansion. Okay, coefficient of linear expansion we will discuss later. And then the relation between them as well. And then if you are talking about area, so this formula actually, before you go to area, this formula actually you can expand more. So you know that delta L is basically L minus L0, right? So I can write down in terms of final length, which is basically L equals to L0 plus this thing. And I can factorize it back, because I can, maybe I can write it down as, just show one over here. So L minus L0 equals to L0 delta T. So I can bring L0 to the other side, and then I have two terms of L0. So L equals to L0 plus L0 delta T. So I can factorize the L0. So this one becomes 1 plus L0 delta T. Hi. And then similarly for area expansion, you have delta A equals to, this one we use the symbol beta for the coefficient of area expansion, A0 delta T. Now delta T and delta S is similar, and then if we expand the formula, we will have A equals to A0 1 plus alpha, beta A0 delta T. Okay, so if we expand, this one actually we already factorize, so that one's no more. Now for volume expansion, delta V is gamma V0 delta T. V equals to V0 1 plus delta T. Okay, so I told you that I'm going to explain more about this coefficient of expansion. So this is what we call coefficient of linear expansion, alpha. This is area expansion, beta. And then the last one is volume expansion, coefficient of volume expansion. That one is gamma. Okay, by definition, it basically fractional change in length per degree in temperature. Or this one is area and that one is volume. So basically, from previous formula, they just rearrange like this one, right? Over here, they rearrange in terms of alpha. You get delta L over L not delta T. So that one is this one. Okay, so basically, it defined as fractional change. So basically, if you have a larger coefficient, so it will expand easily. So maybe you can relate with this one. So if alpha is big, so small changes in delta T will have results in big delta L, basically. And then the unit for that one is per unit Kelvin, K minus 1. But if you want to use this formula for this one, for example, you will see that delta T here is basically T minus T naught. So as long as delta T is in the same unit, T and T naught is in the same unit, you can use Kelvin or you can use Celsius. But make sure the units is the same. No? It doesn't have to use Kelvin every single time, even though the coefficient is in Kelvin. Okay, I think that's it for this subtopic. I think you can try to do the tutorial first.
She says that she loves